Okay, we'll start. So in previous class, we have started module number 2, design of shallow foundation. So in that, we have discussed about the definition of foundation, then the footings, again, requirements for the foundations, types of foundations. They are the shallow foundation and deep foundation. Again, in detail, we have discussed about the shallow foundations, types of shallow foundations. In that, spread footing, combined footing, and strap footing, and mat or raft foundation we have discussed. Okay, so these are things we have discussed. Then the bearing capacity of soil. Then the modes of shear failure already discussed. So now in today's class, we'll discuss about the foundation again and the objectives for the foundation or purpose, why we need to construct a foundation, and also the depth of footings, then the loads acting on the foundation. Okay, so as you all know, so what is foundation? It is the lowest part of a structure directly in contact with the ground and transmits all the loads to the subsoil below it is called as a foundation. And majority of the structure fails due to the failure of the foundation. If the foundation is not designed properly, then the majority of the structure will fail by their foundation failure. And major purpose why the foundation needs to be constructed, the major purpose is to transmit the loads in such a way that the soil is not overstressed. I mean, the soil should not be overstressed and does not undergo any deformation. In such way, you need to design the foundation. For that purpose only, we calculate the bearing capacity of the soil. So whatever the load comes on the foundation, it should be lesser than the bearing capacity of the soil. Then purposes, or you can call it as a objectives for the foundation. The objectives are to support the structure, that is the first one. To support the structure, a foundation is required. Also to distribute the loads over a larger area. Then the minimizes the differential settlements, increases the stability and prevents the overturning, and distribute a non-uniform load uniformly to the soil. Okay, so these are some purposes of foundation. Then what are the foundation loads? What are the loads acting on the foundation? They are the dead load, live load, wind load, horizontal pressures below the grade, structural member forces, uplift forces due to water, then the earthquake forces, and also some other secondary forces also will come into picture. Then here a foundation must resist a dead load. So you all know the dead load. Here the dead load means the weight of the building. The dead load includes the weight of the material permanently fixed to the structure, such as beams, floors, walls, column, and fixed service equipments. So these all comes under the dead load. And this dead load can be calculated if sizes and the types of structural materials are known. You can easily calculate the dead load. And the usual procedure is to assume the self weight. Initially, we assume the self weight, as you know, in the RCC design and all, how the sizes can be arrived at the end. Means initially we assume the dead load, then whatever the size we get, from that size again we recheck. Okay. So the usual procedure is to assume the self weight initially, and the structure is designed, and the weight of the structure is then found from the designed dimensions and compared with the assumed weight. And if necessary, the design procedure is repeated using the revised weight. So that is how we calculate the dead load. That is nothing but weight of the building only. It includes beams, columns, everything. Okay. Then next comes the live load. So here the live loads are the what we call as a movable loads that are not permanently attached. They are called as a live loads attached to the structure, and these loads are applied during a part of its useful life. And the loads, the live loads are a weight of occupants, weight of furniture, and weight of equipments, even machineries, etc. are called as a live loads. And for the calculation of live load, it is difficult to estimate the live loads accurately. So these are specified by local building codes as uniformly distributed equivalent static load. Can anyone tell what code can be used to get the dead load and live load? Anybody knows? You are used in your design of RCC and all. What is the code to be used? Anyone tell what is the code to use to get the live load or dead load?
IS 456-2000, sir.
You know that only one code, that is IS 456. No other codes. You are not used. IS 875 have you used? IS 875 part 1, part 2, part 3. Okay. Part 1 is for dead load, part 2 is live load, 3 is wind load. Okay. So you should know the codes. Then next comes the lateral load. It is because of the wind or the seismic. So wind loads act on all the exposed surfaces of the structures like this. The wind load will be acting on the exposed part of the structure. And these loads depend upon the velocity of the wind and the type of the structure constructed. And like live loads, wind loads are also specified by the building codes. That is IS 875. You will get the wind load, how to be taken and what intensity of the velocity to be taken. Everything is given in the code IS 875. Then comes the seismic. Seismic, again, the force due to an earthquake may act vertically, laterally, or torsionally on a structure in any direction. It may act. The worst condition should be anticipated, and the relevant code is consulted for the design of the foundation. And earthquake load is usually assumed as a fraction of the dead load sometimes, and depending upon the seismicity of the zone, means there are various zones, zone 1, zone 2, zone 3, like that. So you have to refer IS 1893 code. 1893 code you have to refer and get the seismic forces and all. Okay, so this is about the seismic load. And any other such as uplift, other forces also will be acting uplift. This is like this is the water pressure only. The water pressure may also cause an upward force on the bottom of the structure due to the uplift pressure, and it must be contracted by the dead load of the structure. So if you prevent the uplift of the structure, means the water pressure will be acting like this. So the dead loads of the structure to be increased. The dead load should be more to prevent the upliftment. And apart from these forces, there are other forces also will be acting. That is snow loads. Snow loads occur due to the accumulation of snow on the roofs and exterior flat surfaces in cold climates. And the unit weight of the snow is usually taken as 1 kilonewton per meter cube. That is to be considered if the building is constructed in cold areas. And water pressure, as I discussed, water pressure is also acting. Like earth pressure is also acting. Earth pressure produces a lateral force again, like a wind, how the wind force is acting. The earth pressure is also produced because the foundation is buried inside the soil. The earth pressure is also acting. So here the earth pressure produces a lateral force against the structure below the ground surface or a filled surface. The earth pressure is determined using the theories of You know the lateral earth pressure theory, the Rankines theory, the passive earth pressure, active earth pressure, those all theories to be taken and the earth pressure to be calculated and suitably applied for the foundation. Okay, so these are the some of the loads which are acting on the foundation. Okay, so mainly the dead load, then that is the weight of the building to be considered live load, lateral loads, wind, seismic, and other kinds of the forces are to be taken and suitable foundation to be designed. Is it clear?
Yes, sir.
Okay. Sometimes the question may be asked, what are the different types of loads acting on the foundation? You just mention it and explain it. What is dead load, how it acts, live load, lateral load, everything to be explained. Then coming to the depth of footings, how the depth of footings to be decided for a foundation. So depth of footings. So what is depth of foundation? Okay, or foundation depth. A foundation should be provided with adequate depth so that it functions properly. It should function properly in such a way that the foundation depth to be taken. The factors that govern the foundation depth are the depth of topsoil, then the local erosion of the soil due to the flowing water, underground defects such as the root holes, cavities, mine shaft, etc., filled unconsolidated soil, adjacent structures, property lines, excavation and future construction operation, groundwater level, the depth of frost penetration, depth of volume change, desiccation due to heat, boilers and furnaces, then the desiccation due to water drawn by roots of trees. So let us discuss one by one how the depth of footing to be decided. Okay, so these are all the factors which govern the depth of the foundation. So first comes the depth of the topsoil. So depth of the topsoil, the footing should be located below the topsoil consisting of organic matter. If organic matter is present in the soil, on the topsoil, so the footing should be located below it, below the topsoil which consists of organic matter, so which is likely to decompose eventually. Okay, so if you are not taken below the means whatever organic matter is present, if you are not taken below that, then it may damage the footing also. Okay, so you need to take the below the organic matter present in the soil. Then next second comes the local erosion. So this is particularly very important in a hilly area, in a hilly areas where the rainfall is heavy. So the soil in such a situation is likely to wash away to a considerable depth. So the foundation should be placed below the zone of the local erosion. So wherever the erosion of soil is being taking place, so you have to take the below that erosion level. So that is to be safe. Underground defects. If some underground defects are suspected in an area, it should be investigated well in advance of the construction of foundation. No footing should be located above the underground defects like root holes, cavities, buried old vaults, means buried old structures are present. Then the mining shafts or the old wells, sewers, cables, etc. are present. You have to take below that. Okay. Then unconsolidated filled up soil. So man-made or other kinds of fills are under consolidated and they have not attained full strength. If foundation is laid on such a soils, they undergo large total and differential settlements. Okay, and leading to a severe damage or even collapse of the structures. So before deciding the depth of the foundation in such a soil, the strength characteristics should be thoroughly assessed. Okay, is it clear?
Yes, sir.
Okay, please. Right. Next comes the footing on the level ground. Okay. So the footing should be so located that no damage is done to the existing structure. Okay. So whenever you are constructing structure adjacent to the existing structure, so that time there is no damage done to the existing structure. So the damage to the old footing could be due to the shocks, vibrations, undermining of the soil beneath the footing of old foundation, and lowering of the water table. So in such a case, a new footing should be kept sufficiently away from the old one, like this. So if the already existing structure is present, if you want to do the new construction, it is to be taken away from the old one, sufficiently away from the old one. And the foundation arrangement should be made as shown in the figure, like this, the foundation arrangement to be made. So here it is mentioned the old footing and these are the new footings. How the arrangement to be done, just to look here. Below the horizontal plane, this figure shows figure 1. Below the horizontal plane, the foundation arrangement should be made below the horizontal plane. Then the adjacent edge of the new footing must be at least at a distance of S from the edge of the existing footing. This is just here marked is a distance of S, and the S should be, this S, whatever the distance I mentioned here, this S should be greater than the width of the larger footing. So whichever footing having a larger width, that is to be taken as a S distance. That is adjacent, the adjacent edge of the new footing must be at least at a distance of S from the edge of the existing footing, and S should be greater than the width of the larger footing. Further, in order to avoid interference, the minimum horizontal distance S should be greater than the difference in the elevation between the adjacent footings. Okay, that is to be taken care while doing the new construction. So you have to take care about the old structures also. Then footing on the sloping ground. If footing is to be done on a sloping ground, so what slope to be taken for this end? So for footing on a granular soil, if the footing to be done on a granular soil, the line joining the lower adjacent edges of the footing, just look here, the lower adjacent, this line, the lower adjacent edges of the footing should not have a slope steeper than 2 horizontal to 1 vertical. I mentioned it should not be 2 horizontal to steeper than 2 horizontal to 1 vertical. It is shown here. Okay, and in a clay soil, if the footing is to be constructing in a clay soil, the slope of the line joining this, the slope of the line joining the lower adjacent edge of the upper footing. So upper footing having the lower edge and the upper adjacent edge of the lower footing. See, lower footing is having upper edge. So this is the line. So again, the line joining the lower adjacent edge of the upper footing and the upper adjacent edge of the lower should not be steeper than the 2 horizontal to 1 vertical. This is a footing on the sloping ground. Then coming to next one, 7th one, the groundwater level. So as far as possible, footings are to be placed above the groundwater table. So presence of water table may create some problems to the foundation. If the foundation is to be provided below water table, what will happen here? Quicksand condition often create a problem. So water table drastically reduces the soil supporting the power. If the water table is present, it reduces the soil, that is the bearing capacity of the soil. Drainage of the basement floors, waterproofing of basement, resistance against the uplift pressure becomes serious considerations if the water table is present, okay, above the footings. So these all problems will be creating. The next comes the frost action. The footing should be carried below the depth of the frost penetration. So if footing is placed at insufficient depth, it will be subjected to the frost damage due to the formation of ice lenses, or you can call it ice layers. Consequent frost heave. Due to the frost heave, what will happen? The footing is lifted and gets settled down when thawing takes place. So during this process, there will be a significant reduction in the shear strength of the soil and damage to the foundations. So to prevent from the frost damage, the footing should be placed below the frost depth, which could be 1 meter or depending upon the severity, coldness, how much severe cold is. So depending upon that, so the foundation to be taken. So this is about what you call as a frost action or frost depth. And here the footing should be carried below the depth of the frost penetration also. And if the footing is located at insufficient depth, as I said, it would be subjected to frost damage due to the formation of ice layers and consequent frost heaving. And during summer season, what happens? The thawing occurs from the top downwards and melted water is entrapped. And as the soil water freezes and melts, what will happen? The footing is lifted during the cold weather and settles during the warm weather. So the shear strength of the soil, what will happen? It will get decreases during warm weather and due to increase in water content. So to prevent, what should be done? The frost damage, the footing should be placed below the frost depth. So this is about the frost action. And next comes the depth of volume changes. So here, especially in a clay soils of high plasticity undergo large changes in the volume during the wetting and drying process, and they shrink upon drying. The soil will be shrink upon drying and swell during the wetting. So here the volume get changes. So the volume changes are generally greater near the ground surfaces and decreases with the increasing depth. So the significant volume change under the footing may cause alternate lifting and dropping. So if the significant volume change been taking place, then what will happen for the footing? There is alternate lifting and dropping will take place. Then the footing should be placed below the soil strata susceptible to a large volume changes. So, okay. So these all things to be checked before laying the foundation. The next comes the desiccation due to heat. So desiccation means what? The desiccation is the shrinking of soil due to the removal of moisture from the soils. So if when the moisture is been removed from the soil, the desiccation will take place. That is nothing but the shrinkage. It causes severe settlement of the structure. So the desiccation occurs in a soils located close to the plants. So soils located close to the plants like boilers, ovens and furnaces, etc. are not insulated adequately from the ground. Heat from sun also causes the desiccation, and soil like silts and clays are particularly vulnerable to this phenomenon, and these soils become very soft when subjected to water during the raining season. So this is about the desiccation due to heat. Then the desiccation due to roots. Desiccation can also occur in the soils located close to the large trees or the shrubs. So these trees remove moisture from the soils and cause the soils to desiccate. As a result, large settlement can occur in structures located close to the root system of such trees. It is therefore essential that such trees are to be removed from the construction site. And next, one more cause is what? The scouring. The scouring causes a severe damage to the structure located close to the rivers. If the structure is close to the rivers, the scouring will take place, the erosion of the soil will take place. So in such case, the foundation should be placed to such a depth that the effects of scouring would not have any influence to the structure. Okay. So that is the footings which are located near streams, on a waterfront or other locations where there is a possibility of scouring should be placed below the potential scour depth. Okay, the footing to be taken below the scouring depth. And these are some of the what I discussed is the factors which governs the foundation depth. Before laying the foundation or before deciding the foundation depth, these all factors needs to be considered, and which area you are locating or constructing the foundation, that area soil to be tested properly, and according to that the foundation depth to be decided. Is it clear?
Yes.
Okay. Then coming to the minimum depth of the foundation, this is very important. The depth of the foundation to be decided, minimum depth. Okay, for the shallow foundation, it is to be decided based on the Rankines theory. So here IS 1904-1978 specifies that all foundations should extend to a depth of at least 50 centimeter below the natural ground surface. So it is a general rule, or you can call it as a thumb rule. So minimum below that 50 centimeter below the general ground level, the foundation depth to be taken. And however, in case of a rocks, if rock is present, only the top soil should be removed and the surface should be cleaned, and if necessary, the step means you have to take down if necessary. If you want, if you can take down also. And sometimes the minimum depth of foundation is determined from the Rankines formula. Calculate the minimum depth. This is the minimum depth formula. So this one is a minimum depth formula. So d minimum equal to q by gamma into bracket 1 minus sine pi divided by 1 plus sine phi whole square. Okay. So from this formula, a minimum depth is to be calculated, where q is the intensity of a loading. Okay. And gamma is the specific weight or the unit weight of the soil. So this, see, look at this one. This is the ground level and this is the depth of the foundation, minimum depth of the foundation. So remember this formula, we use this formula to calculate the minimum depth. That is the shallow depth calculation. So this formula to be used to calculate the depth of the foundation. This is called as the Rankines formula to calculate the depth of the foundation. Okay. So with this, I'll wind up the today's session here. Just I discussed about what are the loads acting on the foundation, and also the factors that governs the foundation depth, these things. So in the next class, that is, I'll be discussing the proportioning of footing for equal settlement. That is important. That is a design part. And these all things to be taken into account while deciding the depth of the foundation. And also the purpose. This is important also. The objectives are the purpose for providing the foundation and the footing depth. Okay. Is it clear?
Yes.
Yes, sir.
Okay. So please study these all things. And with this, I'll wind up today's session here.